my idea was to have a look at the two major releases for dplyr and ggplot2, because there's been interesting new features popping up, especially for ggplot2. That's what I'll spend most of the time on, and hopefully that highlights some of the most interesting things in the changes. I've got two articles that I'll share with you about the changes. One is from February, that's for dplyr, and it's the version 1.2. So hopefully you've got the latest versions of the packages. So dplyr 1.2 was released in February, and ggplot2 4.0, which is a big milestone, was released back in. As you can see, the news are pretty big, but this was in September last year, I believe. Yes. So those are the two posts I based this on, but they are huge, right? If you feel free to go through this in your own time, but what I tried to do is highlight a couple of things. Hopefully I don't spend too much time on it, and then maybe you might be interested in exploring a bit more. So I'll go to my our studio. I might create a new project to keep things tidy. And then in a script, I'll show you first some ggplot2 features, and I'll finish with some dplyr features. I'll create a new directory. You don't necessarily have to do that, but I do like keeping things tidy on my computer. And probably the most important thing, if you want to follow along, is to check that you've got the latest versions of the two packages that I'm talking about today. So if you check in your packages list, the ggplot2 version that I've got is 4.0.2. So I've got version 4. And if I look for dplyr, I've got version 1.2.0. If you've got an older version, you can update packages with the update button or reinstall the package directly. It is easy to forget that there's big changes in packages. And when you do an update, when you click on update, there's often dozens of different packages that end up updating. And I can see why people would go select all, install updates, and then trust that there's nothing too drastic that has changed in them. But in some cases, there is a big new version that comes out. If there's one of the first numbers that changes, usually might mean that there's big changes, right? But yeah, let's see what's interesting from these two new versions of ggplot2 and dplyr. I'll create a new script for that. I'll save that as my default name, and then we can get started here with ggplot2 4.0. So I want to start with the themes topic, because theming has seen a lot of changes in the last version. There's lots of improvements there, and hopefully some things that make it a bit easier for you to create plots. I'll just open the chat on the screen here. Welcome, Nisa. Thanks for joining today. And just get those messages. Let's see them. So, of course, let's first load ggplot2. And apologies if it's your first time with R. It might be a bit of a steep learning curve to have a look at how ggplot2 visualizations are structured. But again, if there's any question, feel free to ask. And we can get into more details later on after the presentation. So about theming, the first thing I'll show you is that now you can do a lot of theming of geometries or general changes to what colors are used in a plot by going to the theme function rather than changing defaults in the geometries. So, for example, let's create a plot. Let's say that originally you would create something like this. So I'm going to use ggplot with the penguins dataset. That penguins dataset is about a bunch of penguins from different 3 species and 3 islands or 4 islands, I can't remember, and some characteristics about their bodies, sex, and year. And here what I'll do is on the x-axis, I'll put the bill_len variable, and on the y-axis, I'll put the flipper length. So comparing the length of the flipper and the length of their bill. And the main geometry that I'll use here is a point geometry for a scatter plot. So when I generate this plot, this is what it looks like, the usual scatter plot, but let's make it a bit more interesting with another geometry on top. I'm going to use geom density 2D here to have those blue lines on top that tell me about the density of points in different areas. And I also want to add a smooth line on top, a trend line. And finally, after another plus sign, I'm going to apply a minimal theme. So with this plot, maybe we want to customize the colors of the geometries. And originally what we would have probably done is going into each geometry's defaults and say the color for this geometry, for the point geometry, is brown, and that would change the color from black to brown for the points. Maybe I also want to change the density to orange here. And I want it to match also the smooth geometry, the trend line. So I'm also going to put orange for the trend line, right? And if I wanted to change something about the whole plot area, or rather the whole image, I might want to change the background of my plot and say that in the theme function, the general theme function, I also want to change the plot.background color to something else, but I have to use the function element_rect for rectangle. And there's lots of element functions to change different kinds of parts of my plot. And here I can say that the fill color is beige. And close both parentheses, and I get this plot. So I've customized colors for my geometries up here directly in the geometry functions, and I've customized the background of the plot, of the whole image rather, for with the theme function. And that would be what we used to do with, and we can still do with ggplot2. But now it's a bit more streamlined in some way, where you can use what's called paper, ink, and accent. Meaning paper, the background, ink, the main color that's used for most elements that are written on top of the paper, and accent to have something that pops on top of everything else. And I'm going to reuse this code to show you the equivalent with the new version of ggplot2, where I can remove those defaults from the geometries. And I can try and stick to only the theme function. Or even, I don't even need the theme function at the end here. I can remove that one at the end. And I can go into one of the built-in themes, like theme minimal, or there's other ones, theme black and white, theme. There's a few functions that are offered. And here I can say that the paper color is beige. The ink color is brown. And finally, the accent color that's used for the smooth line, for the density lines, is orange. I get something that's slightly different. If you compare the previous one and this one, you'll notice that the ink color actually affects also the labels, the titles of my axes, the breaks of my axes. And also the accent color that's used here also affects the standard error or the confidence interval that goes around the trend line. So it actually makes it a bit more consistent in a way. And it really is about changing the whole plot in one go with one argument, which I think is a lot more streamlined. That can be great to very quickly change the general look of your plot. And you can also define new themes or define geometry options into the theme itself. So one example of that, if we use a different visualization here, I'm going to go ggplot still penguins. But this time I'm going to use the species on the x-axis and on the y-axis the body mass. So now I've got a categorical variable on the x-axis. And I'm going to use two geometries here, geom jitter, as well as geom boxplot. So as a default, it looks like this, where I've given a shake to the points to see where most of them are. And on top of it, I've got a layered box plot. And in the theme function, I can use the geom argument and the element geom function, just like we did with element rectangle, and say that all geometries will use the ink pink. And the paper purple. And you'll see that this affects only the geometry. Or the geometry is plural, right? Because we've got two layered geometries. So now both of those will use pink and purple for ink and paper respectively. So for example, for the point geometry or the jitter geometry, that's pink points. For the box plot, that's going to be pink outlines and lines. And the inside, though, will be purple, because that's the kind of the background. Yeah, so that's how you would affect just geometries, but you can specify that into the theme, and it means that you can create themes that have those geometry colors built in. Now, related to that, a little aside, we'll go back to themes in a minute, but there's also styling changes in geometries that can be really interesting. One example with this geometry that I want to mention, because we're talking about box plot, here what you can do is also style more elements of your box plot that you couldn't do before, so you couldn't style before. So for example, inside geom box plot, I could say that the box line width is thicker. So I'm setting it to 3. See that it affects only the box plot. There's a funny little artifact there in the corner. I'm not sure why. That might be a bug. And then I could also change things about the whiskers and say that the whisker color is equal to black. And now you've got black lines. So these things you couldn't style before, but now we've got new arguments like these to go into the details. You can do that also with the, what's that called? The staples. And you can also style the median line. So there's a lot more options there to make it really look like exactly like what you want. There's other geometries that have styling updates. For example, let's say you create a plot of economics, the economics data set, and I'm going to put on the x-axis the date, on the y-axis unemployment, unemployed, and I'm going to color the points by UMed, which is in this data set the median duration of unemployment. I get nothing because I don't have a geometry. So I'm going to use geom_point here. And you get this gradient that's applied to the points. So that's the original. We always could apply, for example, a gradient to points, right? But now you can also for an area geometry. So using the same code here, one thing that you couldn't do before is use the geom area and apply a continuous variable to the color aesthetic. Although here we do have to change to the fill aesthetic instead of color because it is an area. Actually, did I get that wrong? Error while converting. Ooh, okay. That's not good. Fill UMed geom area. Okay, I'm not sure why it went wrong here, but it did work in positron for some reason. Okay. I'll have to maybe go back to that. If you know what's going on here, let me know. But it looks like it's the graphic device that's struggling. I do have a recent version of R there, so check the capabilities of the PNG device. Yeah, not sure what's going on there. Geom area, fill UMed. Okay. All right, well, I can't show you this one. But it would create a kind of a line chart that is filled underneath and that has that same color here, but going all the way down. And that's something that you couldn't do before. And there's more styling updates for geometries like violin that you can explore, as well as ribbon and labels. Labels in particular, again, there's going to be lots of aesthetics that you can play with, like the borders and the text inside that don't have to be the same color, for example. Now, back to themes. It is a big topic in this version of ggplot2. There's now a distinction between borders and lines, which can be useful, again, for customizing further. So here we're going to look at bill length and flipper length again, and use the same density and smooth geometries. So here we've got point, density, and smooth. We can copy that and reuse it. So this is the original plot. Actually, what I might do here is replace, to make it a bit clearer, might replace the two first geometries with a bin 2D, which creates a grid colored differently depending on how many points fall in there. So it's kind of a 2D histogram with two continuous variables. The color corresponds to how many points fall in each bin. And let's also customize the bin 2D to make it a bit bigger. Let's say that there's 10 bins instead of the defaults. So there's bigger rectangles there. And I want to have a border. So I'm going to say color equals black, which means that it's going to draw a border between the cells. I do have to put that in between quotes for it to work. So now I've got a border between each cell. And I can style that differently to, for example, the smooth line. So in my theme function, I can now say that for my geometries, and again using the geom element geom, sorry, function, I can say that the border width is 0.5 and the line width is 2. So I'm affecting the two different kinds of line separately, which wasn't possible before. So I can change that in the theme itself, right? We could have done this in the geometries themselves. We could have changed the default in each one, but now it's important to know that we've got an option to do that at the theme level and affect all geometries that are used. Now remember that in ggplot2, the power of themes is that you can do all your customizations, make the plot look exactly like you want, and then save that theme as a theme function, a custom theme function, and apply that to all your plots that you're going to create after that. So you don't have to type again and again or copy and paste. Another thing that you can do is change the palettes differently. You can change the palettes directly into the theme function. So here I'm going to add an extra argument here and say that I'm changing the palette in the theme. Here I'm going to use the argument palette.color.continuous, and it uses the same kind of taxonomy as the function, the scale functions that we've used before and that have always been available, where you have to say what kind of aesthetic you want to affect, the color aesthetic here, for example, and the kind of data that you're dealing with. The continuous would be a gradient. And now I'm going to change my values from the beginning to the end of the gradient, from pink to purple, instead of that default blue gradient that's currently being used. And I get my custom color palette, but that's associated to the theme instead of using one of those scale functions that we would have used before. Scale. Now I'll keep building onto this same plot here. And there's another useful thing in this version is that you can break down your theme function into several functions. The theme function is known to have many arguments that are a bit overwhelming, and some of them having very, very long names. And to make your code maybe a bit more understandable, break it down into several parts, there's new theme sub-functions. So for example, here, I'm going to use the theme underscore sub underscore panel. You can see that there's a few different ones. And it's to focus on just one part of the theme. And so you don't have to use those longer argument names, especially if you keep repeating yourself. You see that you keep using the word panel. Now you can break down into several parts and say that my panel will have a set of widths. But before I do that, I do need to do some faceting. So I'll go to just after geom smooth, I'm going to do facet underscore wrap. And the variable that I want to use in the vars function is species. So I'm breaking my visualization into several species facets. So it's broken into 3 panels. Adelaide, Chinstrap, and Gentoo are the 3 species. And now in theme subpanel, I could use an argument like width, which is also a new thing here, where you can specify a fixed value for the width of your panels. Here I'm going to say from 1 to 3, so the sequence of numbers 1, 2, and 3, it's going to be in centimeters. If I run that, I've applied a fixed width to my panels, 1 centimeter for Adelaide, 2 centimeters for Chinstrap, and 3 centimeters for Gentoo. And it doesn't fill automatically the full area of the plot, which is different to what ggsave would do, different to the size of the image in ggsave. So it gives you more power to define exactly what kind of size you want to fix for your panels. A single panel as well as facets if you want. Here I'm using a vector of values to assign to the 3 panels. So here I'll add a comment here, fixed size for panels. And because we're on the topic of facets, there's also a way to change the direction of filling the facet area. So currently it goes Adelaide, Chinstrap, and Gentoo. And because we're using facet wrap, if you had lots of facets, you would have it filling several rows of facets, right? As it needs, it goes to a different row. But you can now have, or use the option to fill the area of facets in different directions. And for that, I can go to the facet function and go direction is, for example, BR for bottom and right. So it's going to start filling the area from the bottom right. And if I run this, you'll see that now it goes Adelaide, Chinstrap, and Gentoo. But it would be more interesting if there was actually several rows of facets. So here I'm changing the direction of filling with facets. Right. Okay, thanks, Nick. So apparently the error I got before with the gradient was Windows specific, but also it seems to be RStudio specific because I was able to run it in positron before. So depending on the operating system, that's one. R is cross-platform, but there's of course always limitations with the operating systems that you're using, and that's one aspect of using R is the graphics. Sometimes the graphic devices differ significantly between operating systems. Thanks for looking into it, Nick. Okay, I might not play with the settings at the moment, but we'll share the solution. Seems to be the case that positron handles that better. Right. Now I want to talk about labels, which is pretty, exciting. I don't know if you find this exciting, but I find it exciting. When we use R to create visualizations, you'll often have labels on the axis that you want to fix because they're labels that are for your variables, as in titles of your variables in your columns that are easy to write in your code, but not necessarily nice to have a look at when it's on the actual plot. And you often have to fix that with, for example, the labs function. But there is, in lots of different packages, column labels are supported. And in a data frame, you can have an attribute to each column that's called label, and that is the kind of the long, understandable version of the title of the column. So I'm going to add an attribute to my data frame penguins, but specifically to the column flipper length. And the attribute is called label. I have to stick to that name so it's recognized, and I'm going to assign to it a full name, flipper length centimeter. And sometimes when you import a data set, depending on the format that you use, the file format, you might already have labels. Right? So penguins is here. Now if I print the whole column, if I say penguins $sign flipper length, then you'll see that at the end, it will tell you that there's an attribute called flipper length, well, called label that contains the value flipper length centimeter. I think also if you look at your viewer, there's the label underneath, which is really handy to make your dataset more easily understandable. But before, ggplot2 didn't support that automatically. It's becoming more common that this is widely used, and it makes sense. And now it is used automatically. So I can say that with the same visualization as before, maybe let's keep the 3 first lines here. Now that we've got this attribute on our column, you see that the label is automatically used. You don't have that ugly title anymore. It makes the most out of what exists already in the data frame, which is really handy. And it makes it a lot easier to, for example, switching your variables, right? Before you had to do labs and say that the Y label is equal to something, right? To fix your labels. And that meant that if you were inverting, for example, X and Y, then you have to also invert your labels, which is extra work. So now if you do Y and X inverted here, you want to flip your plot. Now the label obviously follows because it's attached to the column itself rather than a different function where you've defined again the labels. You can use this, or you can use also a dictionary. There's a dictionary argument. If you've got your labels stored elsewhere, you can use that argument to specify what the labels for the columns are, which is handy. Now, I'll have a quick look at scale breaks, which is a great new addition as well. Again, I'll stick to the same visualization here. But here, I'm going to add a scale function, and I want to change the labels, or the breaks on my x-axis. So I'm going to use scale x continuous. And previously, we had to use where the breaks are, specify where the breaks are, and then also specify the labels if you wanted to change them, right? So that's 2 arguments that have to match. But now we can do everything in the single breaks argument. So for example, I can say that I want a label that's called 200. And it's going to be at the position 200. And I want another one that's going to be called 30 more at the position 230. Close my 2 parentheses, and there's an error. Yeah, I've got an extra comma there. Now this should work. Now you've got your custom breaks and custom labels in the same argument, which saves a little bit of typing, but also makes it less likely that you'll get them wrong, because you've got the value and the label together in the vector, and so you don't have to go from one to the other to match them, which is also a great small addition to ggplot2. Now, another topic that comes up in this release is the fact that now we've got aesthetics for the plots that are associated to the position, in the positions of a geometry. Aesthetics were usable for statistics and for geometries already, but now there's some examples of geometry positions that have their own aesthetics. One example of that is let's use a bar geometry for this one. So I'm going to create a new plot here, still using penguins. On the x-axis, I'm going to put the species, a categorical variable, and I'm going to fill the bars with the island, fill without an E, with which island is the penguin from. And gmbar does a count as a default. That's what the bar geometry does. It counts how many rows fall into that category. So now I've got for 3 different species on the x-axis. I've got different colors for the island that it corresponds to. Now there's different positions for the bar geometry that I can play with. For example, the default is stack, right? Things are stacked on top of each other. This doesn't change anything, but I can also do a fill position to fill up the whole area. Oh, actually, positions is not the argument, it's position, singular. So that fills up and looks at proportions rather than absolute values, rather than counts. And there's another one that's called dodge to put the bars side by side. But when you use dodge, you end up with very large bars when there's only one island per species, whereas Adelie is found in 3 different islands. So now you've got a bit more control over that as well, and you can, in the position argument, you can use a position underscore dodge function with some options in there, including the preserve aesthetic, where I can say that, well, the default is total, which means it preserves the total width of the bar, but you can switch it to something like single to say that it uses a, is it struggling again maybe? Or RStudio? Oh, there it is. Where now it uses just yeah, the width of the same width as the other bars. Yeah, so that looks probably a bit better, but it does put everything to the left, right? It fills them one by one, and that might not be the best. So another option that you can use here is switch the position function to position dodge 2, which this one will center the bars onto the tick of the plot, which looks, in this case, better. Okay, now this is for dplyr, sorry, ggplot2. I'll stop here for ggplot2, even though there's more things. And I'll finish with dplyr. There's a lot less that I want to mention for dplyr. But then we can, after this, we can discuss a bit more. So there's really 2 main topics for dplyr here. The first one is filter route. So I'm going to load dplyr. And the filter out function is kind of the friend of filter, or it does the opposite that filter does. So if you wanted to keep something, you use filter, right? Let's say that we use penguins. I'm going to pipe that into as table because I want it to look nice in the console. I want it to render like this, so it's a bit easier to see what's going on. And let's say that I want to remove the Adelie species from the data set. So we've usually done this by saying filter, which is use a condition to decide on what to keep. And I would have said, sorry, species is different to Adelie. Exclamation point equal is different to, and that should work and remove the Adelie species from my dataset, and you end up with a smaller dataset of 192 rows. And that's okay, but in some cases, it's more intuitive and less likely to produce the wrong result, to use filter out. And filter out will do the opposite of what filter does. Using the same syntax, I'm going to use the filter out function instead, but I'm going to say filter out anything that matches this, that has species is added. And I'll get the same result, 192 rows. But in some cases, this is going to be better and more intuitive. In this example, it's not necessarily the most convincing one. But sometimes when you define, like when you use that exclamation point to invert a logical vector, to invert a condition, it can become easily confusing. So filter out is that to clarify, but also to avoid issues. One important distinction is that filter is for keeping rows. If you want to keep rows, you use filter, and it drops NAs. So if there's missing data for your condition, for example, if there were rows that didn't have a species, it would drop them because you only want to keep the one that match your condition. And then filter out is for removing rows, and it keeps NAs. That's important to notice. And therefore, it matches exactly the behavior of filter, because if you use both conditions with the same, or if you use both functions with the same condition in there, you'll end up with the full data set, right? You're keeping the missing data in one side, but not the other. And it makes sense here because when you want to remove something, you want to remove whatever matches, but then if there's missing data, you don't know if it matches, so you're going to keep those ones just in case. That makes sense? But it is a good addition, and it is likely to help out when you've got more complex conditions. And the last topic here for dplyr is recoding. And replacing, actually. There's a new family of functions in a way that add to case when. In addition to case when, we now have more functions to recode and replace values. So to be clear about what that means, recoding means creating a new column based on an existing one, and replacing is replace values in the column in the existing column. There is a full article about that if you want to explore that in your own time. They've got a vignette. Trying to find that. Recoding Nirvana. Okay, so they've got here that this little table might be helpful. So we've already had case when for recoding and matching using conditions. So creating a new column where you've got a different way to classify the data. If you want to create a new column that matches a specific value, you can use recode values. And if you want to replace directly in the same column, you can use replace when, if you've got a general condition. If you want to match with value, you can use replace values. So this is the full family. And the new vignette is this one that I'll share with you in the chat as well, if you want to explore more this topic, because I'll only give one example of that. So original use would have been, let's say you want to recode the species of your penguins. Let's create an object called recoded. And starting with the penguins, we'll use mutate in dplyr to create a new column. And I'm going to call this one spec short for species short name and say that inside it, I'll use the function case1 to define what happens with what values. So I'll say that, for example, species, if species is equal to Adelie, I need to use the value add for a short name. And my second condition would be species is double equal to gen2. In this case, I would use the short name gen. And finally, species, if it is equal to chinstrap, I'll use chin. So that's how case1 works, is it's looking at the species column. It finds all the ones where there's Adelie, and it will populate the new column with the value add. And once it's done that, it moves on to the next condition, matches this, populates the column. Again, next condition, matches this, populates the column. It goes one after the other. And you get what you were after if you look at penguins recoded. Now at the end, you've got spec short that has the recorded value that corresponds to the first column. But it's a lot of repeating of species double equal. So now the alternative is to use the function recode values. And very similarly, you'll go recoded is penguins. You still want to mutate a column. And spec short is going to be recode values. And where you save some time here is you start with saying which is the column that you want to recode, that's species, and then you only need to list the values that you want to use. So Adelie becomes add, gen2 becomes gen, and finally chinstrap becomes chin. So it's a bit less repetition, but it's exactly the same behavior. Recode values, you specify the column, and then the correspondences or the matching value, and then the replacement value that will populate the new column. And very similarly, you can use replace values, but you probably won't have to use. Actually, do you need to mutate there? Yeah. Not 100% sure there, but yeah. So an example of replace values would be so it's working on a vector here, not a whole data frame. But yeah, that would be the same kind of behavior, yeah. So there's more to this. It's not just recode values, it's also replace values, and it's also replace when, but I'll let you explore that in your own time with that article that tells you all about it. And that's it for me for the latest things in dplyr and ggplot2. Even though I tried to really cut down, but as you can see, there's a lot that has changed, or a lot of new features. This is what I think is the most interesting. Hopefully that's helpful to you to make your code a bit cleaner or easier to understand, or to get you started with, like, say, create new themes in ggplot2.